Good evening. This is Mark. We are reliability engineers. Again, question reliability engineers. We want to share our migration to Istio from our homegrown service mesh. We are talking about more than 50,000 pods. And more importantly, we want to share how we did it and why we did those things and some of the lessons learned on the way. So quickly, I'm going to share who the Credit Karma is, talk about the problem space, our homegrown service mesh, why we picked Istio, how we got there, which is going to be a core of the talk, and then what are the lessons we learned on the way, and we'll spend some time on Q&A if we have time. So quickly about Credit Karma, it's one of the largest financial platform, over 140 million users. Our mission is to champion financial progress for all. I think most folks know Credit Karma to use. They go there to use, check their credit scores. That's how I started using Credit Karma. And over time, Credit Karma has expanded to be a bigger marketplace where you can shop around for home mortgages, auto insurances, credit cards, and most recently, we started allowing people to create their checking and saving accounts and with the aim to automate some of the finances as much as we can. And now you can buy taxes with the products as well. With that, I want to talk about the problem. Credit Karma has been running a homegrown service mesh for 6-7 years now. We were very early adopters, maybe too early, if I'm being honest here. We did that to migrate away from LinkedIn. This was 2018 when Istio was coming up. And over 6-7 years, we have grown. So just going to give more context here. So from the design perspective, the homegrown service mesh is very similar to Istio. We borrowed some of those principles when we started, but have a Go control plane, which does the XDS, provides XDS APIs, all services Envoy proxy, data plane, and it powers all our service-to-service calls. It powers our developer segments, aka preview environments, which allow developers to test changes on PRs. Powers our progressive rollouts, using our rollouts so that we can shift track weights gradually, does simple TLS, and provide consistent observability out of the box. Over 5-6 years, that has allowed us to scale. We've gone from 4 to more than 12 clusters, from 2,000 pods to more than 50,000 pods. Has proven extremely reliable. We've been running it. We've fixed bugs, and that was one of the big challenge when we were at LinkedIn. And more importantly, Envoy proxy has been proven an amazing building block. We've been able to build all those features on top of Envoy. But over time, we started seeing 3 big problems. One was the high operational burden. So for instance, migrating to a more recent version of Envoys used to be really time consuming. We have to make code changes. I don't know how many folks have moved from X2 XDS APIs to X3. That was really painful, expensive. And as we were leveraging the mesh, the team was spending more and more time keeping things up to date, deploys, and we started to fall behind. It started to slow us down. If we wanted to adopt any modern tools, we had to write plugins, customizations to make this work with our homegrown service mesh. For instance, for our rollouts, we have to spend 3 to 6 months writing plugins to making this work with our homegrown service mesh. And we wanted to also up level our security And we had desired to also run our control plane with multiple clusters. So with that, we started looking for the next evolution of service mesh. Again, we were looking for a control plane replacement. We never wanted to move away from the data plane, which has been proven extremely useful at Credit Karma. So with that, we landed with Istio. And again, I want to just quickly talk about the whys. One of the big reasons we chose Istio was the control plane. It was feature rich, allowed us to fulfill our future requirements around KLS and multi cluster routing capabilities. And more importantly, it allowed us to also model our legacy patterns that we have adopted in the homegrown service mesh. We also wanted to make sure that can Istio scale at Credit Karma. And we come to a bunch of big ones. And we have found very few instances where we have seen people are running a mesh of bigger scale than Credit Karma. But as we talk to more people in the community and in the Salesforce folks, they've been running Istio with a bigger scale than Credit Karma. Intuit, which is now the parent company, is also running Istio. So that gave us a lot of confidence. And the reason we wanted to move towards self-hosted was, we've been running mesh for a long time. We wanted to be on the safe side. If we find bugs, we needed full control and flexibility. And we did evaluate some of the managed offering back then, but most of the managed offering were not ready or didn't give us enough control that we needed to run this safely in production. So with that, I want to now just quickly go over how we got there. I think when we started our migration, we started with 3 key pillars. One, when we started the migration, we started with 3 key pillars. One was we wanted to make sure that developers don't have to make any code changes. Why this was important? Because at Credit Karma scale, it's expensive for developers to ask to make code changes. It needs more coordination. And second, it allows us to also now onboard services more quickly. The second big pillar was for us is we wanted to keep the blast radius, the scope as small as possible, which is to us is a service. Can we onboard us one service more safely? Can we roll forward, roll back? And I think the third big thing for us, given Credit Karma is like more than 2 billion revenue, we wanted to make sure as we onboard services, things work without any problem. Things are rock solid. So with that, I want to quickly talk about how we did those. So for us to achieve no code changes, the context behind this is all of the service mesh at Credit Karma is abstracted from developers. What they do high level is they specify this small YAML config in their config. This is how they express other features. And this gets translated to a Helm chart. And behind the Helm chart, we figure out which sidecar to inject in the pod. The second one is the service mesh is exposed on port 4140. And for services to leverage that, they have to leverage this combination of port and the host header, which is we used for traffic routing. And I'm going to talk a little bit more about that. And the third abstraction we have is this traffic routing CRD, which allows to create this mapping of a host header to actual destination and how much weight. So with all these pieces in place, now for us to achieve to onboard a single service to a new mesh, for us to do that, we needed to run both meshes together at the same time. This was our existing state. Services were leveraging our homegrown service mesh. And now for us to do that, what we started doing was we started installing Istio. We started slowly onboarding new services, onboarding services to Istio. And for Istio to Istio services, we wanted to keep
the TLS as strict as possible. So we went with MTLS there. And now for us to work with the homegrown mesh, the Istio services, when they want to talk to the other homegrown services, they use simple TLS. And then we made changes in the homegrown mesh so that the homegrown services can talk Istio using MTLS. So that made sure that we are not going down, at least with our TLS posture. And the third missing piece was we wrote a controller, we wrote an operator that allows us to take our existing CRDs and transforms those to Istio CRDs. And I'm going to quickly talk about that. So very high level, this was the Credit Karma CRD, and the operator used to take this input and transforms this to three objects. One is the service entry, which allows us to expose these services on port 4140. We had to do this to work around because that doesn't happen by default. Second was we had to create the virtual service object, which allows us to create this host header destination mapping and weights. And then the third object we create is destination rule, which creates our TLS policies, and it differs from whether the service is homegrown on the homegrown service mesh or with Istio, and it's also done by the operator. With that, I want to hand it over to Mark.
Cool. So in the next few slides, I'm going to talk about operational excellence and how we managed to not cause a bunch of site incidents and not take down Credit Karma as a whole, which was based on three big points. The automated end-to-end test suite, which we have come up with, the automated connectivity test, and big emphasis on observability across the board. So first, I will talk about the test suite a little bit. So within the automated test suite, we created an integration test, which is continuously validating all kinds of mesh capabilities we have baked in along the way. So we have all kinds of legacy routing patterns, segment routing Sumit was mentioning about, so that developers can easily test their changes, various port behavior, simple TLS, mutual TLS, all of those are codified into this test suite and being exercised in live environments across the board. So we validate that whatever capabilities we are advertising is indeed working in all of those environments in place. Secondly, what we have come up with as like a proactive risk mitigation to prepare for the unknowns was automated connectivity tests. So at Credit Karma, most of our deployments are based on Argo rollouts. And we were tapping into that heavily by introducing a new first analysis step where what we do is basically whenever a service is getting onboarded to Istio, we detect that through Helm charts, and we inject a new analysis step as the very first validation. And what that test does is basically spins up a new job within Kubernetes. It identifies the service dependencies, whatever upstream service it's trying to talk to along the way, and then we just essentially ping the services, hey, can I talk to you? Can I talk to you? And if any of the services are not responding or the response code is not what we are expecting, then we fail that analysis step, thus rolling back the deployment. And we are doing this before introducing any live traffic to the service. And third was the observability. We made sure that very early in the migration, we built a generic yet very comprehensive and easy to use dashboard, which was being used by both the service owners and the platform teams, so that we can very closely keep an eye on all the usual golden signals. Let that be, request volume across services, latency, latest histograms, error codes, various connection level metrics on why connections were torn down or not. And during these migrations, we also made sure to watch these very closely, and we were comparing the old to the new, so that we are making sure that hey, Istio is just as performant, if not better, than our previous homegrown Mesh v2 capability. Now, in the next slide, I'm going to talk about how we rolled out and how we staged this migration. So initially, as what would everybody do is introduce these changes in this test environment. So that's what we did. We started to gain some confidence in our capabilities there with Istio. We migrated a bunch of services in test. Then we quickly followed up migrating those services and white glowing those services in production environment as well. From there, we started to onboard more and more services. These are all like less critical. So let's say if they go down, we are faced with a lower site incident. And this has bought us enough time so that we could backport features from the old mesh, things like fault injection, concurrency limits, rate limiting. Also, we could, while we were doing these white glow migrations, we were demonstrating, that we can migrate and upgrade data and control planes at the same time without any impact to production. We have also figured out how to do east-west routing with Istio ingress gateways. And once we had the confidence that, hey, okay, everything is looking good, we can scale Istio the way we like it, then we started to enable wholesale migrations. That has really helped us to pick up adoption along the way. So as of today, we are at about like 82% of adoption, and we have a few other things to do before we can, cut that long tail off. And in the next few slides, I want to share what we learned along the way. What were the good things, the bad things, and there were some ugly things as well. So what I think, or we think worked really well, is the abstraction layer Sumit was talking about. So the new mesh, from the service owner's perspective, behaves exactly the same way as the old mesh. We could figure out and model all the legacy things into Istio, which was great. This has saved us a ton of time and energy on aligning with hundreds of service teams, coordinating between those. We haven't had to figure out automation to do those migrations. So it gave us time as well so that we could work on backporting features. Also, what worked really well was the stage rollouts. And the dual mesh operation. It has prevented any kind of showstopper issues. We could preserve the blast radius to a single service during its deployment ramp rather than a big bang change across the board. We made sure that the service owners have an easy and straightforward way to roll back the change if they had to, or they felt like that, hey, there's something off, so I'll just roll back. And again, this has given us time. And thirdly, what I wanted to mention is the early investment in proactive risk mitigation, right? So Sumit was talking, for example, about mesh operator. Operator pattern is kind of tricky. There is a single leader pod in a whole cluster-wide environment. And whenever you are rolling out a change, that's a big bang migration, right? So we figured out a way on how to do, for example, dry runs. In every single cluster, we were able to identify, hey, if we were to deploy this version of mesh operator, these are the changes we would see on the actual Istio CRDs. We have also caught issues with automated connectivity tests. The comprehensive end-to-end test suite has proven really good as well. Just a couple of days ago, we caught an issue with concurrency where, if you were deploying into a segment with certain concurrency limit, that was applied across the board rather than on just your segment. So that was not very fortunate. It hasn't caused any SIs. So what were the challenges during the way? So this is where we really learned that technical depth is real. So Credit Karma has been around since 2008. That means that Credit Karma has went through the VM world, then we migrated into Docker world, and now we are in Kubernetes runtime environment, right? And this means that we were accumulating a whole lot of tech debt with various routing constructs which were already legacy, and we had to support those in order to get this done. Some we were not able to support, and this migration has been a great forcing function to pay down that tech debt. So at the end of the day, we had to write a little bit of automation here and there to migrate those services away from there. But a few more examples like short host headers. So Sumit was showing like service a.service. Some service owners just omitted the last part and relying on that resolution, and we couldn't get that working, for example, with Istio, so we had to move away. We got some other services which were using the health check port to do like non-health check traffic, and that was difficult as well to make it work with Istio. And the other bigger problem we had was the inconsistent environments. We made some assumptions that, hey, if things are working in test, why wouldn't it work in prod? Well, that's you all know that's a very bad assumption, unless you can prove it. So our lesson learned was invest heavily in environment parity and automated config validation, because it's going to bite you. Now, what are some of those ongoing challenges we still do have? So Credit Karma is a GCP shop. We are relying heavily on managed services like workload identity and Google Certificate Authority Service. We issue those MTLS, like short-living MTLS certs through Google CA, right? The mechanism was not really documented well previously, but I think in 1.23 it got straight up removed. So that we are still figuring out a way to how to work around that. And secondly, keeping Istio at our scale up to date is really tricky. Istio has like a couple of months of life cycle, right? And just to push through every single release through a release pipeline and introduce it to every single cluster, even with stable revisions, is operationally really tricky. So long-term support is something which we need to look into. And lastly, I think this is not surprising, scaling metrics at this scale, this 50K pod scale, is non-trivial. So the data volume and high cardinality is leading to super high costs and various performance issues. And for example, we are doing Prometheus observability. Some of our Prometheus agents are running and scraping with more than 100 gigabytes of memory because we are doing some pre-aggregation to get rid of certain metrics, and that is not very reassuring. So we are thinking about more pre-aggregations in our metrics pipeline to move away from that. And I would like to wrap this up by just reiterating the key takeaways for you folks. So abstracting the service mesh with backwards compatibility has really paid off for us. It has saved a ton of time with aligning with other teams and making sure that those changes are rolled out. The other big thing that we managed to not cause any high severity site incidents was due to the phase rollouts. We highly recommend that. Also, what paid off was the early investment in testing and observability. It has helped us to debug issues and get into the root cause of a couple of problems. And what has also helped us is engaging with the community. So we were talking to both the Istio community and other heavy users of Istio, and this has really helped us to hone down on what direction we want to go. And lastly, what I want to mention is this whole migration has took a village. So many thanks to the whole team and ex and current team members and other teams within Credit Karma for the support. And with that, I would like to thank you, and we are happy to take any questions. We are around during this week, so you can come to us and talk and do more deep dives. Any questions? Okay.
No?
What are the main benefits you got from switching?
So my question is actually pretty simple. I think Mark, right?
Yeah.
You mentioned about the Google CAS.
Right.
So so currently the mesh I set up, I use a cert manager, then call it AWS PCA Azure. So have you tried that with the GCP?
We are considering using Cert Manager as well. We have various security constraints where Cert Manager doesn't give us the right security posture, and it would downgrade our security. So that's why we are trying to look for other ways of supporting Google CA.
Yeah, thank you. Interesting.
Hey, hi. Can I go ahead?
Sorry, I think we are at time, so we'll come to you and talk to you.
Yeah,
Folks.
do you have any authentication and authorization in your CRDs that you developed? Authentication?
In the Credit Karma CRD?
Yeah, you told you have developed a custom control plane or data
Yes.
plane, right? Yeah. Do you
No, that's enabled by default. Like we do not let folks configure that. And by default, we with Istio we're doing MTLS, and with our homegrown service mesh we were doing simple TLS.
Okay, yeah, thank you.